Algebra 1, Lesson 8, using unit analysis to convert measures. So basically, it's a lesson on unit conversion. You guys should already be familiar with how to convert units because I feel like I remember teaching this in middle school, okay, that you guys have already learned some of this. Unit analysis is the process for converting measures into different units. A unit ratio compares two measures that have the same amount. Okay, 12 inches is the same as what? 1 foot. 2.54 centimeters is the same as what? 1 inch. 5,280 feet is the same as 1 mile. 100 centimeters is the same as 1 meter. 1,000 meters is the same as 1 kilometer. Okay? All right? 2.2 pounds is the same as 1 pounds is a measurement of weight. What's a 2.2 pounds the same as? 1 kilogram. Okay? All right, so we can switch between units if we know what they're equivalent to. Okay, we can set up ratios that are equal. All right, and since the amounts used in a unit ratio are equal to each other, a unit ratio is always equal to 1, which keeps it balanced. Okay, since the product of 1 and a number is that number, a unit ratio multiplied by a measure will always name the same amount. It won't change the amount. Let's see. May not have been this class. Was it this class where we were talking about? No, it wasn't. It was Algebra 2. Whenever we're trying to balance an equation, and I can see where I would maybe need to add 6 to both sides, right? We call that the addition property of equality. It keeps it balanced. It doesn't change the value, okay? So we're looking to keep things, we're not looking to change the value of anything, we're looking to change the units. So that's really all that's being addressed here. Now, your book does say, and I don't think I typed it out, but it's at the top of page 39, so at least I'll read this off. It says unit analysis can be used for more than just converting units of length. Right? You notice that one of my last questions was, what is 2.2 pounds the equivalent of? All right, well, pounds is not a measurement of length, but a measurement of what? Weight. Okay? And really what's interesting about that question is that when we start talking about kilograms, that's actually not a measurement of just weight, but of mass. Okay, mass and weight are two different things. Does anybody know the difference between weight and mass? This is a good science question for you. What's the difference between weight and mass? Does your mass ever change? Can your weight change? Based upon what? Gravity. Because gravity on the moon is not the same as gravity here. So what you weigh can change, but you will not. Okay, that's the difference between mass and weight. A kilogram is a kilogram on the moon, the same as a kilogram is a kilogram on Earth. Okay, because it's a unit of mass. Okay, now a kilogram may have different weight. Okay, because what we're saying is that on Earth, the equivalent to a kilogram is 2.2 pounds. So it can also be used to convert units of mass, density, temperature, capacity. What might we, when I mentioned temperature there, what might we want to convert in terms of temperature? Celsius to Fahrenheit, or Fahrenheit to Celsius, right? You ever hear people talk in Celsius? And it's like, man, it's really hot outside. It's like 6 degrees Celsius. You're like, I have no idea what you're talking about. I don't think in Celsius. All right, we think in Fahrenheit. What would be a warm temperature in Fahrenheit? Like 90 degrees, right? All right, capacity or even money, right? Money conversion. If we were trying to convert money, what might we convert? Okay, so cents to dollars. What else could we convert in terms of money? How else might we convert money? What's that? Gold. All right, so metal value into dollars. Okay, how else? I'm thinking of maybe something maybe a little bit more obvious. That is kind of a conversion, But let's think a little bit more globally. Mexican money. Okay, so pesos to dollars, or dollars to yen, or the English pound. There are different types of what? Currency. Currency is the word I'm looking for there. Okay, so we can convert currency. In economics, the value of money is defined by what people are willing to exchange for it. Our money used to be based upon the value of gold. Then it changed to the value of silver. And now I think it's based upon interest or interest rates or something like that nature. It's really kind of ambiguous. This means that the value of currency can change relative to the value of other currencies. You've ever watched the really boring news stuff where they say that the value of the dollar is going down or the value of the dollar is going up compared to currencies in other countries? All right, an exchange rate listing shows what a currency is worth compared to other currencies of that at that moment. I have several friends, they're missionaries to different countries, and so they go around the country, they go to different churches, and they try to raise support so that they can live in those countries, right? And what they find out is that the value of the dollar here may not be the value of the dollar there, so they may have to raise more or less money depending upon what the value is. All right, let's see if we can't pull up a couple of questions here. All right, let's say we wanted to convert 226 centimeters to meters. Okay, 226 centimeters to meters. What would I need to do? I need to multiply by the conversion, right? And so, here, let me kind of clear that out. Is 226 centimeters here, is it in the numerator or denominator position? It's in the denominator position. And if I want to convert, I'm going to multiply, but I want centimeters to be in the opposite position because I want centimeters to cancel out. Does that make sense? All right, what do I want on the top? A foot? What am I trying to convert to? Meters. All right. Let's see. Now, when I'm using a conversion, one of my units should always have the number 1. Okay, do you know which unit should get the number 1? The meter. Why the meter? Because it's bigger. Okay, it's bigger. The bigger unit will always get the number 1. Okay? All right, so what goes on the bottom? No? 100. 100. Why 100? All right. And 1 meter over 100 centimeters is equivalent to what? 1, right? Because they're the same thing. So am I changing the value? My goal is not to change the value. My goal is to change the unit. So I'm going to take 226 times 1 over 100, which is really 226 divided by 100, right? So what do I get when I take 226 and divide it by 100? 2.26 meters. Okay? What did I say we got out of here at 31? All right. Let's try to do at least one more, okay? All right, we want to convert yards to feet. Okay, so I'm going to start off with 9 yards. Okay? What needs to go on the bottom? What unit? Yards. Okay? What needs to go on top? Feet. Which one gets the number 1? Yards. Yards are bigger than feet. How many feet are in a yard? 3. All right, so what am I going to do? 9 times 3 divided by 1, so really just 9 times 3. So how many feet are in 9 yards? 27 feet. Okay, does this make sense yet? Okay, have we done this before? Yeah, so feel like we're good to go. We can do all of this. All right, there's several other questions in there that you can look at. We have, now these questions are good questions to look at. Why might these be good questions to look at? They can help you on your essay, right? Because they give you examples of how something could be used in real life. I don't want you to write down the question as your essay answer, though. Okay, does that make sense? Okay, I want you to be original. I want you to be thoughtful. Like I said, if I get a really well-written response to that essay question, this is being recorded, right? So you can pull back the recording and play it for me. If you give me a really good response, really well thought out, really intelligent, I'll give you a homework pass. Okay, that means that whatever assignment that you choose to use it on, you'll only have to do the lettered questions. Okay? So worth your time to actually think about it.